A curve has equation y equals fx, where fx is 4x cubed plus 8x minus 4 over 2x minus 1. We need to find an expression for dy dx and the coordinates of the stationary points. To find an expression for dy dx, fx is the ratio of two expressions. This can be written as u over v. So when we have the ratio of two expressions, to find dy dx, we apply the quotient rule. So dy dx here is given by v du dx minus u dv dx all over the square of v. V is given by 2x minus 1. Now we differentiate the numerator, so we find du dx. Du dx is given by 12x squared plus 8 minus u dv dx. U is 4x cubed plus 8x minus 4. Du dx is a 2, and this is divided by the square of the denominator. We have 2x minus 1 squared. Now for the numerator, we need to expand that. So 2x times 12x squared, that will give us 24x cubed, and we have 16x minus 12x squared minus 8. For the second part here, remember that we need to distribute the negative and the 2 here. So to distribute the negative and the 2, we have minus 8x cubed minus 16x. The 2 negative will give us a positive 8. And we take all this and divide by the square of the denominator. Let's look at the numerator to simplify. We have 16x, negative 16x, these two are gone. Positive 8, negative 8, gone as well. So we have 24x cubed minus 8x cubed, that is 16x cubed minus 12x squared, all over the square of 2x minus 1. That will give us an expression for dy dx. To find the coordinates of the stationary points occurs when dy dx is 0 or when dy dx is not defined. In this case, we don't look at the case where dy dx is not defined because the function is not defined at that value of x. We only set dy dx to 0. So when we set dy dx to 0, we have 16x cubed minus 12x squared over 2x minus 1 squared. This is 0. A ratio equals 0 only when the numerator is 0. So that 16x cubed minus 12x squared is 0. And for this part here, we can factor 4x squared, and we will have 4x minus 3 equals 0. So the product of two terms equals 0. Either x is 0 from 4x squared equals 0, or 4x minus 3 is 0, and this will give us x equals 3 over 4. To find the coordinates of the stationary points, we need to find f of 0. We replace x with 0 into the original function fx here, and that is negative 4 over negative 1, which is a 4. One of the stationary points has coordinates 0 and 4. The second stationary point has x coordinates 3 over 4. So we replace it into fx. We have 4 and 3 over 4 to the 3 plus 8 times 3 over 4 minus 4. all over 2 times 3 over 4 minus 1. And that will give us a value of 59 over 8. So the second stationary point has coordinates 3 over 4 and 59 over 8. Then these two forms the coordinates of the stationary points. Part B, we need to divide 4x cubed plus 8x minus 4 by 2x minus 1. We can either use a long division or the synthetic division. It matters not. Because the coefficient of x is 2, it's safer to just use the long division. So 4x cubed divided by, we have 4x cubed divided by 2x, and that will give us 2x squared. So we have 2x squared here. Take 2x squared, multiply throughout by 2x minus 1. That gives us 4x cubed minus 2x squared. Subtract the second line from the first line. So we do not have an x squared term. We have 0x squared minus negative 2x squared. So that is 2x squared. And then we have plus 8x minus 4. Now take the first term, 2x squared, divide by the first term, which is 2x here. And we get x, so plus x. Now x multiplied by 2x minus 1 is 2x squared minus x. Subtract the second line from the first, we have 9x minus 4. Now we have 9x divided by 2x, that is 9 over 2. So we have 9 over 2 in the quotient here, and then 9 over 2 multiplied by 2x minus 1, that will give us 9x minus 9 over 2. Subtract the second line from the first line, and we have negative 4 minus negative 9 over 2, which is negative 4 plus 9 over 2, and that is 1 over 2. From here, we say that 4x cubed plus 8x minus 4, when it is divided by 2x minus 1, we have the quotient, which is 2x squared plus x plus 9 over 2, and a remainder of 1/2 here over 2x minus 1. That is the division process, the first part of part B. The second part of part B, hence, find the integral of fx. To integrate fx with respect to x here, instead of integrating that, we just integrate the result from the word hence. We must use the result that we obtained previously. So we integrate 2x squared plus x plus 9 over 2 plus 1 over 2 over 2x minus 1. Integrate this with respect to x. That will give us 2 over 3x cubed, and this will become 1/2 x squared, 9 over 2x, plus this is 1/2 here. It's just a coefficient. When you integrate 1 over 2x minus 1, that is a log function. You have the log of the absolute value of 2x minus 1 over the coefficient of x, which is 2. And we have a constant of integration. So you have 1/2 x squared. And that 2 and 2 becomes 1/4. Then we have 1/4 log of 2x minus 1 plus c.